Hello everyone and welcome back. In today's video, we are diving deep into computer vision to conduct a head-to-head comparison between two powerhouse architectures. On the left split screen, we have the ultra-fast YOLOv11, and on the right, you are seeing the highly precise SAM3. We will running these models side by side to critically analyze the differences in their detection speed and segmentation quality. But we won't stop at just comparison. Further in the video, we will build a complete player tracking pipeline. We'll integrate an OCR library to automatically recognize jersey numbers from the video feed. And finally, we will break down the game tactics by generating dynamic heat maps of player movement. Let's get started.
Hello everyone, in this project we are going to see how computer vision can be used in sports to transform raw game footage into professional grade analytics. Usually this level of player tracking requires expensive stadium cameras, but today we are going to see how we can build a system that automates player detection, reads jersey numbers using OCR and visualizes team tactics, all using deep learning and Python. So this is our notebook for this project. This is the objective of our project as I mentioned earlier. These are certain important libraries that we need to install like OpenCV, NumPy, Ultralytics, Matplotlib, and Torch. The first step will be that we need to clone the repository of Labeler, which will help in certain functions that we will perform later. First of all, you will need to upload a video dataset on which you want to perform the annotations. Like I have used this video here. This video is of a basketball match. Now we will perform player tracking and analytics to see how the players moves, and we will also use OCR for player recognition by their jersey number. After uploading the video, we need to extract 50 random frames out of it so that we can perform the annotations on it. For this, we will use the library which we cloned earlier and import this function extract random frames. It will cut our video into 50 frames and which we can do annotations. After the function is completed, we can see the random frames dataset has been formed here. Here is our 50 images that we got by using this function. Now we need to perform the annotation on these dataset frames on the labeler platform. Now you can see I have performed the annotations on the 50 images and these are the results. As you see, I have marked team A, team B, the basketball, the referee, and also the basket. I have done it for the 50 frames. You can see like this was the first. Now I'm reviewing the each images. See, the annotations has been done. Now we'll just need to export it into Coco JSON format. I have uploaded the annotations from the Labeler website to my project folder, and now I have renamed it simply for new annotation.json for simplicity. Now I will convert the Coco to YOLO format. Again, I will use the Git repository that I cloned earlier and import this function Coco to YOLO converter. It will just convert my Coco JSON format to YOLO. I have kept the train ratio 0.7, validity 0.2, and test ratio 0.1. Now the next crucial step is our model training. We will be training our model on both YOLO and SAM to compare both of them, that which model predicts what outcomes. First of all, we will need to install the Ultralytics library, and then we will train our model on YOLO first, YOLOv11 segmentation for 50 epochs. After training, we will get our best.pt file here. See, I got here. Now the next step will be run the inference on our raw video. We will use the best.pt file that we got and do the inference on our raw video. After doing it, we will see what outcomes comes. It trained for around 1600 frames. Let's see the output. So this is the output that we got. You can see the players has been marked along with a bounding box and a polygon across them. Even the referees are also marked. You can see the basketball is also getting traced and the basket that we are going to use is also getting marked. It has been done for a longer 54-second video and the outputs are clear. Now I just want that the marking has been done but not the bounding boxes as it looks a bit cluttered around them. So I will use this code and put the labels off and mask through but boxes off. Then you can see that it for one frame you can see that the bounding boxes has gone but the players has been detected properly. But now I want to update the color of the players and the referee because it looks a bit similar. You can see the referee color is almost similar to the player team B color. And I also changed the color of team white as well because the white color is not good at all. We will use the green color for the team A and blue for team B and put the referee in yellow color. I have marked the color scheme here. Now see the output for one frame first. Yeah, we can see that the blue color is marked along with green and yellow for the referees. Yes. Now we will apply this for the whole video. We will use the same color scheme as the frame above we see. Now processing for the whole loop. Okay. Now we'll see the output that we got after it. This is the output that we got after removing the bounding box from it and applying only the mask layout on the players and the ball. You can see that the output is not too satisfactory as the pairs are looking like a bit blurred. Now we'll try to implement the logic using the SAM3 model as it's more precise and accurate in marking the players. Let's see what's the code for the SAM3.
Now we will do our inference on our video using the SAM3 video segmentation, which will use the text prompts. Instead of traditional bounding boxes training, this approach leverages text to segment capabilities, allowing us to track specific objects like basketball player, referee, balls, all using natural language prompts. To get started, first we need to get the model of SAM3. You can use the Hugging Face. There you have to accept the license and have to wait for the access to be granted. Once the access is granted, you can simply download the sam3.pt file. Then we will use the integration with Ultralytics. We will use this function inside the Ultralytics, which will help to do the inference on our video and help us to give only text prompts, which will generate the predictions in the video. So here's the code overview of it. Like see, you can see the text prompts. I have kept the basketball player wearing white jersey. So it will detect the players which are wearing white jersey and will try to segment along it. And similarly, I have done for the blue jersey as well and referee and the ball. And I have kept the labels off and boxes and confidence to be off to keep it more precise and clean. Now we will try to run it on the video and see what's the output come out of it. So this is the output video that we got using the SAM3 prompt. We have just simply given the prompt that we want to detect the white players, blue players, and the balls. And you can see the all the things have been marked properly. Even the referees has been masked. The blue team players and team A players, it's able to identify both the team players individually along with the referees and the ball. So SAM3 has made our task very easy. By using YOLO, we have to do annotations. Now, by using the SAM3 prompt message, we can just get the text and it will auto-generate the masking of the players and ball.
In this step, we upgrade our pipeline from simple frame-by-frame detection to persistent object tracking. Using YOLO's built-in tracking capabilities, we assign a unique ID to every player. This allows us to record their movement history and draw trajectory lines behind them, visualizing their path across the code. So here's the full code for it. We will running this code to get the track of each player around him, and we will also see their past trajectory as well. After running this code, we'll see what's the output came. So this is the output for our code. You can see the pairs has been marked by the bounding box and a trajectory line has been there. Each team player has been marked with their team ID, team A and team B. In normal tracking, the track ID which is assigned to the player is totally random, but we want that the track ID which is assigned is actually their jersey number. To implement this, we will use the easy OCR library which reads the jersey number from their jerseys and then it gives as a track ID to them. By using this, we will use the logic that vote threshold means that we will look at their jersey 2-3 times and if it's recognize the same number, then only it will give the track ID. To improve the accuracy, we have done this. First of all, you need to install the EasyOCR library. After installing, then we will run this code by importing the EasyOCR here. And this will give the assigned track ID to the individual by looking at their jersey number. This is the whole code for it. Now let's just see the track ID that we got. This is the output that we got. You can see that the track ID which is assigned to the individual is just by looking their jersey number. We have used the EasyOCR library as I referred earlier. You can also implement this. You can see that a 23 digit has come here. Each track ID is given accurate. You can see the whole video like that. We have kept the referee same, but we have implemented for the team A and team B players. The next analysis we will do is the visual heat map, showing that which player has spent the most time in the code. It processes the video, tracks player position, and accumulates heat in a matrix to visualize high activity zones, or we can say hotspot. We
If
will
you'd
see
like to
that in
explore
which
practical
region the player
resources
has
and
come most,
hands-on
and
examples,
we
we've
will
created
get
a
a frame of
dedicated
it.
GitHub
This is
repository.
the whole code
It's
for it.
filled with cookbooks covering computer vision,
And this is
AI
the final
agents,
frame that
and
we
more.
got. You can see
Link is in
at
description.
this region the activity is highest. This is the highest hotspot zone, and we also got the real-time video analysis for it as well. Now we'll see the video output of it as well. So this is the video output of our heat map. You can see the region which has most players in it has become red and become the hotspot region. And you can see this is the region which has the most player activity. So this was all for the YOLO versus SAM3 model comparison video along with different analytics which we saw using easy OCR and heat map. These are some other popular videos of Labeler on YouTube channel which you can check. Stay connected to our website, blog and GitHub channel as well. Thank you.
If you enjoy our content and want to see more, don't forget to hit subscribe.